Welcome to the little lecture on the phases of the moon. Let's understand where we are first. This is Earth, dark side, light side, because the sunlight is coming from over here. Here's the moon on what we're going to call day 1. Notice that the side of the moon that's toward us is not lit because the sunlight is hitting the back side of the moon. Now the back side of the moon we normally call, and Pink Floyd normally calls, some of you will get that, the dark side of the moon. But notice the dark side of the moon is not dark. The simulation has an error in one way. The moon always keeps, let's pretend like this is its nose and feet. The moon always keeps its nose toward the Earth. So while the moon is going around us, we always see the same side of the moon. It's a little bit weird. Imagine you did that to your mom or dad. You went around them, but always kept your face towards your mom and dad. If you had a note like "kick me" on the back of you, they wouldn't be able to see it. Well, we never see the "kick me" note on the back of the moon, known as the dark side of the moon, which is lit half the time because it always keeps that side away from us. Now, notice what time of day we are seeing this moon. You're going to see it overhead at noon. A lot of people don't realize the moon is out during the daytime. Really. On occasion, the moon is directly between the Earth and the sun. You can't tell from this, but remember that the Earth's axis is tilted 23.5 degrees to the sun, and the moon's orbit is tilted 5 degrees to that of Earth. So very rarely does the moon come between the Earth and the sun. It could happen every month, but it doesn't since we're not all in a line, like flat on top of the table. Let's go to day 1. Look what happens. Oops. Okay, day 1 1/4. By this point, if you're on Earth, you're no longer seeing the moon directly overhead at noon. You're going to see it directly overhead at about 1 in the afternoon or 1:50, something like that. And if you look very carefully, if I drew a line from here to this side of the moon and from here to this side of the moon, you're going to see a little bit of light on the right, as exhibited in this picture in the upper left. Let's go all the way to about 3.5 days. You'll notice the Earth is rotating around 3.5 times. You might be feeling dizzy about now. At 3.5 days, we've moved from what was the new moon to what's called the waxing crescent. Waxing means not just to get brighter, like waxing your car or your bicycle, but also means to grow. The lit portion of the moon is growing. I like to think when the light is on the right, the moon is gaining might. It works. Let's go 3.5 days later. Notice we're going to rotate, and notice what's happening to the size of the lit portion of the moon. Again, the simulation is an error because it's not keeping the back side of it away from us. But overlook that for now. At day 7.5 approximately, you're going to see this. The half of the moon that we see is half lit. What's a half of a half? It's a quarter. So this is called the first quarter moon. Let's go another 3.5 days, but speed it up a little. And at this point, we can call it day 10.5. I went a little bit too far. Actually, day 11. This is called the gibbous moon. And again, because it's growing, it's called a waxing gibbous. So we've gone from the new moon to the waxing crescent to the first quarter, or the waxing gibbous. What time of day are we going to see this? Well, sometime after sunset. Let's go back again. This is at noon. This is going to be in the afternoon. This we will see overhead at sunset, which makes a lot of sense because the sun is over here, we're rotating around, the sun is setting over California for us, and the moon will be directly overhead at sunset. We will see this 9, 10 o'clock at night at our zenith, the highest point in the sky. And at about day 14 or 15 into the moon, you're going to see this, the full moon. Now again, because the moon is not actually on the surface of the computer screen like the Earth and the Sun appear to be, it's actually above the Earth or below the Earth. Very rarely does it get blocked by the Earth. But the Earth does block light hitting the moon much more frequently than the moon blocks the sunlight hitting the Earth, simply because the moon is small, Earth is big. We're the bully. I know we're supposed to stop bullying. That's the way it works in astronomy. Can't get around it. And if you did, that would be revolving. Okay, full moon. Overhead at midnight. Yes, it rises earlier. Let's take a look. Okay, at about day 18, 18 and a half, this is what you're going to see. It's just like this one, but the opposite. The light is on the left. When the light is on the right, the moon is gaining might. When the light is on the left of the moon, it's leaving. Now, I should stick in a little point here. If you look straight up at the moon, this left and right thing won't work. You have to lay down on the ground and tilt your head left or right, and that's how you can tell which side of the moon is being lit. Why? You need to be in line with the Earth's poles. Okay, to do that really well, in Phoenix, you should lay down at an angle of about 33 degrees tilted to the south. So put a lot of pillows under your head and then look at the moon. If it's on the left, the light is on the left, the moon is waning, the light is leaving. Let's move all the way up to about day 21, day 22, and the third quarter. In this case, what you're going to see from the Earth, imagine you're on the Earth, is the light is going to be on the left. Right now we will call this the third quarter moon, and 3.5 days later, the waning crescent. Looking at the moon from the Earth, you're going to see a little bit of light on the left, and you're going to see mostly dark, as shown by this little dotted line. Now, how long does this take? Well, it's a little bit confusing. For the moon to go around the Earth one time takes 28 1/3 days. But while the moon has been going around the Earth one time, what has the Earth been doing? It has been moving around the sun. Oop, don't do that all the way there. Over here. So in order for the moon to get back between the Earth and the sun, it has to go all the way to 29 1/2 days. Let's go through these one more time. Here's the new moon, seen overhead at noon. The waxing crescent, the light is on the right, at about day 3.5. Seen overhead, 3, 4 in the afternoon. The first quarter, seen overhead at sunset. The waxing gibbous, seen at zenith or overhead, probably about 9 at night. The full moon, you can see it anytime you're on this side of the Earth, but when is it overhead? At midnight. The waning gibbous, the third quarter, and the waning crescent. And then back to the new moon. Again, 29.5 days. We have a time period named for this. The amount of time it takes for this large object to go around us is called 1 month. You've heard the old westerns where the people are talking about many moons? Well, this works out really well. The only problem is there are about 12.5 moons in a year. So if we based our months on moons, that'd be a little bit weird. So we just lengthened our months a long time ago. Maybe the moons would be better, who knows? But you get the idea. Know your phases of the moon.